prior to actually getting started running a sample on the XRD, what you want to do is you want to prepare the sample. So when you're preparing your sample, you can actually make it in a fume hood in room 5034. Use ideally a mortar and pestle, like an alabaster one, something that's smooth. And what you want to do is you want to grind it very finely into a fine powder that you can actually smooth out later on. Okay, so this should be okay right here. Okay, and this is just KBR right now that we're working with. Then we'll grab a spatula, and we'll use one of these plastic holders with a low background silicone wafer, and it just rests in the center here. Any one of these can be used. So we're just going to get a little bit a spatula tip worth of your product, sort of drop it right in the center of the silicone wafer, and then just lightly try and push on the surface to smooth it out towards the center. Yeah, so ideally you're trying to center it, and you're trying to create a spot, maybe 0.2, 0.3 centimeters a radius, so that it's enough sample to actually get measured by the X-rays. So something of this sort, okay? And then we're going to actually put this into the XRD, and we'll start with our measurement. Okay, so the next thing we're going to do is we're going to put the sample in the XRD. To do that first, we're going to actually pull on this knob, pull towards and up to release it. And you can see the sample holder. You actually have to drop it by pulling this down. And the sample can go directly in here now and rest right in the center here. And then pull the knob back up, push the sample up towards the chopper, and you have control over whether or not you'd like to, you can actually pull the chopper out here, and you have control over whether you want to have a 1 millimeter gap or a 3 millimeter gap, your choice. We'll start off with the 1 millimeter. I'll just flip it, and it's magnetically held in place here. One other thing to note is when you do use the 1 millimeter side of the air scatter screen, please make sure that the scatter screen does not touch your sample. If it does, simply pull this out and just wipe the outside of it, and then place it back in. And that's all we need to basically do on the inside of the instrument in order to prepare it for your measurement. And we'll just close this back down again, wait for a click, and it's closed. So once the sample is actually in the instrument, the first thing we're going to do is go behind the instrument and turn the key that enables the high voltage. We'll turn it slightly horizontal so that it's enabled. So first thing that we want to do is open up the tray here where we have the keyboard and the mouse. And usually the computer should be locked. So the first thing that you want to do is press Control-Alt-Delete. And it should bring you to this window where you have to put in the password to get into the Windows embedded system, which in this case is actually password, all lowercase. And it gives us access to the desktop. Go to the software, which is called diffract.measurement. Double click on the icon. And be a little bit patient at this time. Usually it can take up to 1 or 2 minutes to actually fully open. You will come to this login screen where, as long as you have the login name as Lab Manager, there is no password protection. So all you have to do is just hit OK. And once again, just be a little bit patient so that the software can pop up and you can see it in a state where it's communicating. And you may get a few signs on the side here on the far right indicating that certain things are off. They usually will go away on their own, as they just did. And at this moment, it's actually fully communicating. You can see all the values on the side here with numbers, and both your start and stop buttons are enabled. And what you usually can do at this particular time, or the options that you have in order to run your experiment, are typically down here. So the time, step number, 2 theta values, you can adjust them. They're all down here, and it'll also give you an estimate of the total time to run your sample in seconds. So in this case, you're looking at something that'll take about 700 seconds or almost 12 minutes. In our case, for 2 theta, you can run it anywhere from currently from about 7 degrees to about 90. In this case, we'll just leave it at 82.7. The time, integration time, is about 0.25 seconds, which is typical. And the steps are a result of both the integration time and your 2 theta values. And in this case, it tells us it's going to be about 11 minutes to run the sample. So there's three more parameters that you may want to pay attention to before running making your measurement, running your sample. That first and foremost being voltage and current here. Settings are for 30 kilovolts and 10 milliamps. These 2 values should never be adjusted. They're set intentionally to get the best measurement that you can. So please remember not to touch those. Lastly is variable rotation. For those that will feel that they'll need to actually rotate their sample, you can adjust this value to a maximum of 15, and it'll spin your sample at 15 RPM while you're making your measurements. Please do not go above a value of 15. At above 15, there's always a chance that the sample may actually start spilling off of the wafer and into the chamber. Nobody wants that to happen. At this point, you're pretty much ready to run, and all you need to do is hit start. And what you should do is once the high voltage and the X-rays are enabled, you'll see these bright lights up top, and it should remain on so long as the experiment is running and your X-rays are on. So this is an important factor to keep in mind when your experiment has run, to make sure that they actually turn off. And you should be able to follow your collection in the spectral window right here once it starts. All right, so at this point, the collection has stopped, but as you can see, the lights are still on, indicating that the high voltage and your X-rays are actually both enabled and working. So at this point, you can either hit stop, although once in a blue moon, what will happen is the data won't save properly if you do that, or you can simply go to the X-rays right here on the side panel and select off. And once again, you'll get a couple of messages indicating that the high voltage is off and that sort of thing. It's not an error message, it's just letting you know what you just did. And at this point, it's safe to open up the instrument if you'd like. And in fact, what we'll do is we'll open it up and remove the sample, same way that we put it in. And then we can work on basically saving your data and extracting the data from the instrument onto a USB stick. So. first thing we can do is we can go to File, Save Result, and create a folder here if you don't already have one. Create a new folder. Enter. And then go into the folder. And at this point, what you're going to do is you're going to create a file name for your data set. And let's say just test. And what you want to do is you want to save both the .brml file format, which is the Bruker file format, so you can open up your data set. And we'll do that first. And we'll go back in, save result, and we'll, from file type, we'll go to text, and once again save the data set as test. Oh. Save. So basically you want to do that because with a .txt format, you can actually open up the file in a number of offline software packages that are free, and you can actually open them up there as such, and as a BRML as well. So it makes sense just to save both your single data set in both file formats. So now that you've actually saved the data, what you can do is simply just close the program. Do you want to exit the application? Yes. And what we can do is we can put the USB key at the back of the instrument in so it can recognize it. To put the USB key in, make sure there's actually 3 ports, top to bottom here, that you can use. The only one that's actually active that you can use is the one up top. So just make sure you put it in. And it should be available in a matter of half a minute. Be patient. Wait for it to show up under My Computer and as a removable device. Once it's available, that's when you can use it so that you can transfer your data. And then we can actually start saving the data. So Start menu, My Computer. The results are under C, Documents and Settings, All Users, Application Data, Bruker AXS, and Results. Go to your directory, select the files, Shift, copy them, go back to your USB stick, and just paste. And here are your files. So once again, now that you've done that, you can close this. So at this point, what you'd like to do is eject your USB key that you've just used to transfer your data and safely remove it. And now it can be removed. And in the meantime, you can basically go to a lock screen, Control-Alt-Delete, and lock the computer until the next user gets to use the equipment. Finally, I typically would turn off the monitor from underneath and leave it in this state. And the last thing you want to do is the first thing that you did originally, which is actually turn the enable key for the high voltage, which is at the back of the instrument. And what you want to do is you want to turn it so that it's vertical now. Make sure that you do this last step just to make sure that it's always in off position when it's not in use. Cleaning off your sample, off your wafer. Make sure we'll have a waste can basically for it. You can actually just dry wipe your sample in there, and to be extra clean in case the sample has stuck onto the surface at all, just wet Wet your Kim wipe with a little bit of isopropanol and just wipe it down to remove the remainder of it. And it dries pretty rapidly. And you're ready for your next sample. So for those of you that are going to wish to do low angle measurements, let's say from about 2 to 5 degrees or above, what you need to do first and foremost is on the software, you'll need to adjust the PSD opening right here. It should be the value here. If your 2 theta begins at, let's say, 2 degrees, then your PSD opening on your detector side should be half of this value. So in this case, it should be 1. So now we're going to open the instrument. And what we're going to do is we're going to look at the hardware that's going to need to change in order to set it up for low angle measurements. The divergence slit is the first thing that we're going to need to change. If we pull this out, and this one in particular is the one that's for 1 millimeter, and what you're going to do is you're going to replace it with the divergence slit at 0.1 millimeters and just slide that back in there. Secondly, we're going to get a hold of the air scatterer, and we're going to flip it from the 3 millimeter side that we had to the 1 millimeter. Place it back in, and then lastly, we're gonna place the scatter slit, a 3 millimeter scatter slit, on the secondary side of the instrument. It will fit in the instrument right in these grooves here. Push it up, and you should hear a click when it's in place. And that's the last thing you need to do for your low angle measurements in terms of preparation. Please make sure when working in this particular space, the fume hood is where you're supposed to be making your samples, cleaning your samples. Make sure that the bench space beside the instrument is kept clean. Pretty much everything except for possibly the holders should be the only thing at the bench. And keep in mind, this is a departmental instrument, and for perennial offenders, be aware that this will be brought to your PI, and it's a possibility that your use of the instrument can be suspended if you don't follow these rules. Last thing to note, sometimes the software may freeze, or there may not be any communication to the instrument. Please do not shut down the instrument. Do not attempt to restart the software. Do not attempt to shut the system down to reset the system. You may have some unintended consequences that we don't want to deal with, so please contact the facility manager should the occasion arise. Do not attempt to do this on your own.